Hi there, hello everyone. Welcome back to Code Conyo. So for today, I am going to show to you three different algorithms in converting decimal value or an integer value to binary equivalent, which is, of course, as we all know, binary digits are either zeros on one or ones. So as you can see, we have the first method that we have or that I have created here is that it's iterative approach which implements while loop. Okay, so and in while loop, the this method is going to accept the value of n. So when the value of n is greater than or equal to 1, so the execution or this statement or this block of statements right here inside of while loop will be executed. So this will concatenate this part of in our program would concatenate the value of the value after you get you get the remainder when n is divided by 2, which is because of this n modulus to 2. So basically, this would either give us zeros, 0 or 1. All right. So obviously, when a number is add or when an n is add, the value that is going to be to yield is an odd number, which is 1. When it is even, it is going to return 0. Then when it returns 0 or 1, or when it gives 0 or 1, it is going to be concatenated in the bin. Okay, and then after that, so that our loop will end or will terminate, of course we'll need to decrement the value of our n, making it the end to be updated until it is going to be 0. So let's say for an instance we have here like 10. So obviously this is like 10 is greater than or equal to 1, and then so when it is 10, so we'll have the bin. The value of our bin is what they call this one is empty. So it's an empty string. After that, it you will have here the what they call this one n modulus to 2, which is the value of 10 divided by 2, and the remainder of that is actually 0. So 0 plus the value of our bin, which is empty, is equal to a string or a converted string 0, which is converted into a string. Okay, and our n would now become n divided by 2, which is now 5. So 5 is so our loop will now execute this one again. So because it's repetition, so this would have 5. So 5 is greater than or equal to 1. This is true. So I just forgot. This is actually true. So when it is true, then therefore the last value of our bin is actually zero string. Now this time 5 modulus to 2, the remainder is actually 1. So 1 plus the bin value, which is 0. Okay, so is equal to 1. Okay, is equal to 1 and 0. So that is now the value of our bin. Then this one here, right here, would be now 5 divided by 2 is actually 2. Okay, so why is it 2? Because n it's an integer, n divided by 2 is an integer division. So unless we put here 2.0, this would now become like a float. The value would be uh, divided, and the result should be floating point, which is supposed to be 2.5, something like that. But since it's an integer division, 5 divided by 2 is actually 2. uh, yeah, 2 mathematically it's 2.5, but in programming, since it's an integer division, it's only going to return or give us 2. Okay, so now after that, this will have here 2 greater than or equal to 1. That is true. And then right here, you have the n modulus to 2, which is 2 divided by 2, the result is 0. So we have here uh, 1 0, or 0 plus 1 0 is equal to 0 1 0. So this is now the updated value of our bin. Now, in the next line of statements, you have here 2 divided by 2, which is 1. So this time you have here, it will go back to the while statement or while block. So we have here 1 modulus, greater than or equal to 1. That is actually true. Then you have here 1 divided by 2. It's actually 1. Okay. So we'll have here 1 plus 0, 1, 0. So you have here the bin value, which is equal to 1, 0, 1, and 0. Then you'll have here n modulus 2 divided by 2 is actually 0. So when n is 0, so you have here 0 is greater than or equal to 1. That is actually false, which makes this bin has the updated or final value as 1010, which is bin is going to be returned there. So let's try. So you have here system that out that print line. We have recurse that decimal to binary n. Let's say we have here 10. So let's say if the value of our n is 1010. So there you are. We have 1010. So it's actually equivalent to the built-in function using integer. Okay, integer that to binary string. So you have here, let's say 10. So the integer to binary string is a method, it's a built-in method in Java, which we use to convert decimal value or an integer value into binary. So you have here 1010. So that's it for now. Thank you for watching this video. In the next video, I'm going to discuss recursive function equivalent of this decimal to binary. Thank you and have a great day ahead.